Hi, my name is Samanwaya Mitra, and today we're going to learn about Gauss law. So, what is Gauss law, and does it have any theorem? And we'll be also trying to prove the Gauss theorem in electrostatics. So, let's begin our first. So, Gauss law was given by Gauss himself, stating that if there is a surface, if there is an arbitrary surface where there are charges enclosed, it has to be enclosed. It has to be enclosed. Charges enclosed, then net charge enclosed by epsilon naught will give us the electric flux linked to the surface. Basically, the statement in pure mathematical terms is given by phi equals to Q net by epsilon naught. Phi s for surface. Now, what does that mean? Suppose if there is an arbitrary surface that is made over here, there are charges plus Q, plus Q, plus Q, and plus Q over here. What is the net charge enclosed in the surface? 4Q. So the total flux will be equals to 4Q by epsilon naught. Now, if in this arbitrary surface, there is charge plus Q, minus Q, plus Q, and minus Q is there. What is the total net charge enclosed? Plus Q minus Q will become 0, plus Q and minus Q will become 0. So net charge enclosed is 0. So flux is 0. So flux is 0. That means if a flux linked to a surface is 0, that does not necessarily mean that there are no charges that are linked to that surface, that are there enclosed in that surface. That may mean that the net charge enclosed in the surface, the sum amount of all the charges is 0. So we cannot say that if there is a surface, arbitrary surface like a sphere or rectangle or whatever, and inside that there are charges are there whose sum amount, if we do the sum amount, that is 0, that means the flux linked to the surface is 0. We cannot say that the rectangle has no charge present. If it is mentioned that there are no charges present inside the surface, no charges enclosed, then we can say that the flux linked to the surface is 0. Okay, so let us move ahead with Gauss law a little bit. Gauss law states also one more thing, that the net flux linked to a surface is the surface integral of E dot ds. Now, what is E dot ds? E is basically electric field, and ds is a small surface element, area element of that surface integration. So we are trying to do is that we are trying to integrate the dot product of electric field and a small area element over the entire surface, and then we are getting the flux. To prove this, and this is equal to how much? This is equal to Q by epsilon naught. To prove this, we can use an arbitrary surface over here. Okay, there is a charge plus Q present somewhere inside it, and it is subtending an angle d ohm, a solid angle subtended at the center. Okay, now at this point P, we have to find out the electric field strength, which is in this direction, and the ds will be along this direction. Okay, the area element vector, and these two are making an angle theta. Okay, now what is the electric field strength at point P? that is E equals to 1 by 4 pi epsilon naught due to this charge Q by, let us say that this distance is R. So we can write it as 1 by 4 pi epsilon naught Q by R square. Now, this is the electric field at point P. So E dot ds will basically give you d phi. This is not line integral. I'm talking about E dot ds only. E dot ds will basically give you d phi. That means we are talking about only this section of the surface. The flux linked to this section of surface is E dot ds. So what is E dot ds? 1 by 4 pi epsilon naught Q by R square dot ds vector. Now this can be written as 1 by 4 pi epsilon naught Q by R square ds cos theta, where theta is the angle between ds and E, that is equals to d phi. Now ds cos theta by R square, ds cos theta by R square is equal to the solid angle subtended over here, d omega. Okay, so d phi is equal to 1 by 4 pi epsilon naught Q by R square d omega. Now let's integrate the equation. D phi is equal to Q by 4 pi epsilon naught integration d omega. So this becomes phi equals to, now obviously there is only one charge enclosed, that is why we have taken only one charge. Q by 4 pi epsilon naught comes out of the integration d omega. Now d omega integration over here with respect to the solid angle integration over the entire surface. What will that give? D omega integration will give us 4 pi. So phi equals to Q by 4 pi epsilon d omega integration, that is 4 pi. 4 pi gets cancelled. Phi equals to Q by epsilon. This is the mathematical statement of Gauss theorem, which has been proved by using by placing a charge in an arbitrary surface and trying to find out the electric field at a place which is at an r distance from that point. This is the answer to the question. Hope this solves your question. Hope this solves your concept, and have a nice day.